Hello, I'm Robert Toomey. I'm a research developer at the National Severe Storms Laboratory in Norman, Oklahoma. In this tutorial, I'm going to focus mainly on ingesting data into an algorithm, basic output, and notification. I'll cover how to use the built-in help and show some of the built-in options for algorithms. I'll probably show some examples using the real-time flag and sync options as well. So let's get started. In this tutorial, I already have a full build of RAPIO, including MRMS. If you don't have one ready, you can look at the first tutorial for some help and tricks on doing that. So in my build, if I go into RAPIO, and I go into the example algorithm, if I run this without any parameters, I get a dump of the default help for the algorithm. And you also get things like description of the algorithm, the authors involved, and examples. And when you code an algorithm, there are plugins in the API for you to fill this out for your algorithm. But all algorithms will have the basic RAPIO options, which are defined globally across all algorithms for consistency. So at the moment, I want to focus on the input-output ones. So here we have little I, little o, big O, and n. The big thing about the little i's here are about your data ingest, obviously, and your o's are about your data going out. And the n is about notifying about data that you're writing out. So you can think of the notification here as how do you send your metadata record for new data. So this is like, think of it like SQS in Amazon or any other notification system. We write little FML files that contain the metadata for our actual data. So the capital I is about filters. This is about if you're bringing an input source, your input source may have, for instance, you may have reflectivity data, velocity data, a bunch of different types of data are coming in that stream, so to speak. And this capital I is the ability for this is to filter that and to only get the data that you're interested in from that particular stream. With the capital O, it's similar. It tells patterns for actually writing data out. So this allows you, for instance, to turn on and off whether a product is written out or not. Say your algorithm writes 3 products. You could set a filter here in real time so that it just doesn't write out 2 of them. So that covers the basic I/O functions, kind of. But let's look at a little more detail. So if you do our simple alg help and I do little I, you'll get the advanced help for options. And this is where it really, I think, is more useful. So this is your ingesting. This is telling you all the different ways you can ingest data that are built into RAPIO. And this may change over time, but I'll just kind of briefly cover what's currently working. So I can actually ingest from a stream. So let's say I want to watch metadata from a LDM stream. So I can actually set it to the feed me, because this is the built-in, the LDM watcher program is called feed me. So you can do a feed me-f text and actually filter, say, FML records directly from LDM without having to read files off disk. This cuts down on I/O. You can also point to an executable that say you wrote an executable that looked at an SQS queue. You could listen to records from that and then use that source to write your output. And we have the FAM and IFAM. The big thing to notice about the current ingesters on the RAPIO is that there's this IFAM versus like FAM. The difference is that I always refers to, say, the metadata. So IFAM means that it's watching for FAM files. So this is like the default in the old system. The old system, we just do a code index FAM or whatever it was, and we would get FML files that would be in that directory, and we get notified. And I'll show you an example of that here in a little bit, just to make things more clear. The FAM is more for like ingesters. So let's say you just have files going into a directory and you have an ingester that you're writing, then you would actually use this to watch that folder for any file, and then you would process that file with the ingester when it came in with that. So right off the bat, if you're used to MRMS, you can see that this is kind of expanding upon what the ability of that system was. Then we have the polling. This is for instance, I'm polling for an index versus polling or using IFAM. If you have things like network drives, things like that, you might not have inotify ability. Like I've noticed it doesn't work, and you have to have a Linux kernel access to get the IFAM working. So and then we have a web one. This basically is what you call this is the WG one. So if you look here, you'll see this. This should be familiar to you if any of you used a WG display or even WG2. Basically, we have a mini web server that serves the data over the web server. So and it has an index that is actually pulled on a timer. So this is that ability for that, so that you can actually pull data from that. And I'll show you that example as well. iXML, this is an index of an XML. This is the traditional code index.xml file, which you're used to. And then you have polling to watch the directory. This is kind of the counterpart to the FAM up here, except this is using this is just looking for regular files. So you kind of see how the basic thing works. So let's look at some examples, I think, of it running to actually give you an idea of what's going on. So if I go up to MRMS, I have a folder here called example data. And I'm going to go into this, and there's KTLX. And this is actually an ancient archive we have that's the May 3rd, 1999 KTLX data archive. And you'll see I'm in this folder now, and I'm in a radar name, but you'll see a reflectivity folder. So if I go into that, you'll then see these numbers like 0.5, 1.45. These are the elevation angles. So if I go into that, you'll see I have a bunch of .NET-CDF files, and they're compressed in this case, but it doesn't really matter. RAPIO doesn't care. It automatically recognizes things are compressed or not. But so we have this partitioning scheme that's based on radar, data, product, moment type, and elevation, say, and then we have time. But if we look at this code index.xml, you'll notice a bunch of these little XML records. Now they could also be, I think RAPIO also handles JSON as well as XML, but the basic idea is that you have information basically that says what the time information is and the data and the actual file. And the system uses this in order to ingest and to look for the actual file and ingest. So these records can be used, these metadata records are used for notification. So let me just go back into the builder, or excuse me, the algorithm. If I'd been smart, I would have had it auto tab back and forth, but okay. So I've got some scripts here that I've made, and they show some basic way of running with settings. So the first thing I'll do, I showed you that archive, right, where it has that code index.xml. So if I look at this script here, actually let me go vim it so it has some color. But you'll notice that you've got the -i, and it's an index XML, right? So here's the path to that code index.xml file I showed you just a second ago. So the important thing is that, RAPIO can be explicit. You could also take this off because basically the old system, anything with XML in the end, it would just automatically assume it was this. But in RAPIO, you can be explicit if you want, just to be a little clearer. And then you'll just have input velocity. Now remember that data set had reflectivity and velocity, right? So what I'm telling it is, I'm saying when I run this thing against this index, I only want to match products that match velocity. So I don't care about the other part of the data set. I don't care about the reflectivity data in this case. I could make this a star. I can do velocity star right now. It might actually, change over time where we'll actually enhance this even more. And then I have an output, archive velocity. And I have a -o star. This is the default. Basically what I'm saying is I want to write out everything. So since our simple algorithm is mirroring data, and I'm just writing out a product, if I bring in a velocity, it's going to write out a velocity. And it's going to write out to this folder. Since I have the star, basically it's saying that I don't want to turn anything off. Now, in this particular case with the mirroring algorithm, it really doesn't make much difference. But if you had, say, an algorithm, like I said, if you wrote 5 different products, you might still need to calculate those 5 products internally in order to do your analysis, but you don't want to write all 5 to disk, or someone may want to turn it off. So system admin may use this filter to either turn off products or change the name of products. So if say you're writing out your default product name to write out is velocity delta or velocity 2, I could actually use this string here to translate velocity 2 into velocity whatever I need it to be so that it works with data in a larger system where other things, you may be running multiple versions of this algorithm and you want to make sure that they all get unique names on output. So that's a very important thing to be able to have that ability. And this verbose thing here is just the logging level. So if I run this, I'm going to go ahead and run this archive test now. You'll see RAPIO is doing its thing. So this is just basically each of those products are coming in. And you notice that you don't see any reflectivity here. You're just seeing velocity if you can read it fast enough. And I'll go ahead and let this run. I think it only takes about 20 seconds or so. Okay, so it's done now. So you'll notice that it gave you a time and it stopped because we were running it in archive mode. If you notice, there's no -R, and I'll talk about the -R option in a second. Actually, I'll talk about it now. So if we go to R, those of you familiar with MRMS know that the -R, you had real time or you had no -R, in which case it was just archive mode. RAPIO kind of has expanded ability to where you can actually do things like you can just do archive mode, which is old, which you just run all the records and stop. New, basically, this basically says only process new records. So if you connect new to a web index that has 10,000 records and a new one's coming out every 30 seconds. If you run it with the new, you're not going to look at any of the old records. You're just going to get the newest record and then continue watching the newest record in daemon mode until the algorithm is stopped. Right? If you do all, it's going to go through all the 1,000 records of the archive, and then it will sit there and wait. So you can kind of see you got control over how you do it. Either you're looking at the old records, you're looking at only the new records, or you're looking at both. Right? And that's what this -R is about controlling. So if we look at this archive velocity that we ran, you'll notice that there's a CodeIndex.fam. And the reason for this is because this is our -n. Our default notification always goes to the output directory and writes fam records. This is just to be consistent with the old system. So if I look at one of these individual fam records, you notice it's very similar to that code index XML file we looked at. This is being generated by RAPIO as it writes the data out. Now the reason why, of course, is because other algorithms may be looking at these files or watching these files in order to know there's new data record available for them to go further down the processing chain. And you'll notice there's only a velocity folder, right? All right, so that's your archive. So what do we want to do next? Let's look at the web. So I'm gonna look at a web instance. So here I'm going to basically run this algorithm, and I'm going to connect to KTLX data running on SR20. And this is a macro form of that long web URL that reads. But since it's an iWeb, it's going to be looking for indexes. And I'm looking for reflectivity only. I only want reflectivity data. And I'm going to do old. So what this means, remember the old means it's going to read all the records that are currently available. That's going to stop, right? Because it's archive mode. And I'm going to output a reflectivity test. So let me go ahead and run that. And hopefully the KTLX didn't die when I started up the algorithm, or it's actually running. And you'll notice, there it goes. This is actually the current records that are available in KTLX. So when I go into reflectivity test, you'll see there's a reflectivity folder, and there's a CodeIndex.fam like before. See, and those are the current records as of this current time they're available. And there's the elevation angles, and basically the data has been pulled down and cloned. Maybe this is a good time to actually show the makeindex script. If you have MRMS, you have a W2 makeindex. Also, RAPIO has a makeindex.py. What this script does is that it will analyze files that are in a current format, and it will create a archive XML file. This is more needed for MRMS old algorithms, because I don't think old algorithms could archive read off of FAM directories, but RAPIO can read off a FAM directory and not really need a makeindex.xml. So this is more for backward compatibility MRMS. But basically what it does is it scans files and it creates the records, and it basically says what builder is used. So right now, netcdf, these are all XML files, JSON, grib2. I've added a few in here for experimentation. So where were we? So anyway, let's actually run that script now. Let's just run it. Now we did a reflectivity test, right? So I'm going to run this, and I'm going to run it on reflectivity test. And you'll see that it found 34 records, and it wrote an XML file to makeindex.xml. So if I edit that, you'll see the code index. It's basically all the FAM records stuffed into one file. This is also the iXML input parameter in RAPIO. And the only thing special about this, you get its index location. This basically is a relative path based on the folder that you're in, so they can figure out where the files actually are. Okay, so the next thing I want to do is I want to look at the web notify. So I haven't talked about the notifiers yet, so let me do that real quick. So if you look at the notifier advanced help, you'll notice two things. You'll have one that says FML, write an FML file to directory for each record. This is the way you're used to it in MRMS. You're just writing to you're writing to an output directory, code index fam by default. You can change this, and you just basically FML equals output. Or if you have the .fml in the end, it knows it's that. Couple of things RAPIO does that MRMS doesn't is that you can set it to disable, which I've found since you have I/O involved. If you actually set this to disable, you can speed up your archive processing a little bit, because you don't need to notify if you're doing a gigantic archive, right? If you're doing 100,000 records or 100 million records, whatever, and you want to run it for 3 hours or 10 hours or a day, then you don't need to be writing out all these notification records, because you're not doing anything else with it just then anyway. And the other thing about it is that you also have this exe. This is the other thing that's majorly different. And what this does, we had some algorithms in MRMS that would run a script or program on a file after it got written. So it would do a converter on it or something. It would want to do something after the file got written. And there were some hacks and some algorithms that did that. And this is RAPIO's way of doing it more generically. Basically, every time a product is written, it calls the executable for what you call, and it with the final file name. So some use cases of this could be post-processing. Let's say you have a data set that you want to, you're writing out records and you want to graph them or something in Python. You could actually write a little Python script and do it this way. I mean, you could use the Python interface as well, but depending on your use case and what you're actually wanting to do, this might be more efficient in this case. So that's the notifier. So if let's go back to the notify example. So here I am inputting from the web, outputting reflectivity. It's the same as the other example. The difference is I'm going to call this exe notify.py. So pay attention to this here, this -n, all right? So you think, what is that doing? So let's look at the notify.py. So I whipped up this script like in 2 minutes, but basically all it does, it takes the first argument, which happens to be the file name, and I just basically append it to notify.txt. And you notice that file's not in this directory. So let's run the web notify. Let's see what the difference is. So I'll just let it run all the way through. All right, so there you go. But notice now I've got a notify.txt in the directory at the end there, right? So if I read this, you'll see that the name of the netcdf file has actually been appended every time a record was written. So you can kind of visualize what the use cases of that would be. Okay, so what's next here? Let's do the IFAM example. So remember, we use inotify, right? So I did go over, I talked about the difference between FAM and IFAM, right? So FAM is watching a directory for any file, and the IFAM is watching a directory for our metadata FML files. So I'm going to watch this directory, the FAM1 directory here, for FAM files that have velocity in them, and I'm going to mirror them because our simple alg is mirroring without any changes in name or filter or anything like that. And the only thing is I'm going to put this -r, and the reason why I got the -r, the -r default means real time. It means basically new. It's the same as new. And I got verbose info, but that won't do anything different. So the reason for this test is that what'll happen is that I'll run this guy, and it's just hung, right? Well, what it's done is, you notice a successful connection to IFAM FAM1. So what this is doing now is it's watching that directory for incoming FML files because of the -i. It's not looking for files, looking for FML files. So I'm going to switch my scene here real quick. Okay. So we'll let that run, and I'm going to go back to I'm in the home directory now. So you see this FAM1 directory. There's nothing in it, right? So what I've done is, I've made a FML file that just happens to have my test data directory in it, velocity and information from that directory. So when I copy that file into that FAM directory, just pay attention to that background window. Right? You'll notice that it responded to the FAM message, processed it, and the data was read and it was written. And it will just do that forever. It doesn't care. I'm going to go ahead and cancel it. And you'll see in the FAM radial test, let's see what happened. We have a code index FAM. So it wrote out, right? It wrote out the file that it noticed. And in the velocity, we have our netcdf. I think I've got compression turned off for output. Okay. The last example is going to be the run sync. And this is another feature that was kind of wanted in MRMS a long time ago. But basically, I'm going to leave it with the same FAM directory because we're not actually going to read any data this time. But it would read data. It would read data just like the other one if we put data in there. The difference is, you know, this is -sync option here. And what this is a 6-character cron format. So what I've told this here is I'm gonna get a heartbeat to this algorithm every 5 seconds. So, and I'm not gonna teach you cron format. You can look that up on the web if you're interested. Or you just, I think you do man cron. Yeah, man cron will tell you the details of that if you're interested. So what that's gonna do is that if we wait, every 5 seconds it's gonna get a heartbeat. And the default just says, what do you want to do? It's, if you look at the sample algorithm, it's only doing that. So that's not very, very fancy. I also turned on the verbose equals debug mode. So when I canceled the algorithm in that case, it gave me a stack trace, which is why it dumped all that. See over here, the debug. But basically what you do is you can get real-time data coming in. Let's say you want to get a collection of lat-long grids for an hour and you want to accumulate them, or you want to average them, or you want to, something like that, but you only want to write out a synchronized time output. So with the synchronization flag, you can do things like that. You can basically collect your data internally, add it up, and when you get the 10-minute timer or the 1-hour timer, you can fire. The advantage to it over cron is that since it's a daemon, if you take longer to write than the time window of the cron, you don't get stacking processes, which is a big problem that we have. For instance, if you're outputting every 2 minutes with a cron and it takes you 3 minutes to write your output, then you end up stacking up your processes and flooding your system and basically crashing it, right? So if this way, with this synchronized way of doing it, if it misses a time window, you just get the next time window. So as long as your algorithm keep up, you get as much time as you want. If it doesn't keep up and it needs more time, then you have to deal with it. So I think that covers all the basic, I think I covered all the basic options on that. Okay, so I remembered one more thing I should probably talk about. And if we go to the help for the algorithm, we'll see we have this iconfig and this oconfig. And basically, there are two types of files that we can read or write as part of the command line itself. So if I do a help on the oconfig, if it ends with XML, it writes a WYSI type file, and it writes a .config, it writes an HMET file. So these are the configuration files for the old legacy system. So let's see, I made one for MRMS make. And if you look at this, I've got the -oconfig to mysettings.xml. And I've got these settings here as input from the web and reflect. This is the web archive test we ran earlier. But you notice it's got a bunch of options. But if I run it with that -o, you'll notice instead of actually running, it stopped. It wrote an XML file. In this XML file, you'll see that all the parameters, including ones that are defaults or whatever, all got written to that file. So I can now run my algorithm by using it as the input. And if I want to, I can override settings in that file with command line options. So you can see how this could be very useful if you had an algorithm that took, say, 500 parameters or something. We have some algorithms that take a lot of parameters. And you'll see it runs the web test just like it did before. I'll let that run. If I stop it, it'll stack trace because I set it to debug. And I also have the ability to do the HMET files. So I think MRMS allows you to input the WYSI XML file. But since HMET uses the flat files with colon pairs, we also have the ability to read and write those files as well. And that's it. So I'm going to end it now. And the last thing, of course, is to tell you where to get it. And the builder itself is at github.com, RAPIO builder. And the source code, if you want that particular, is the github.com, RAPIO. And there'll be more tutorials later. And thank you for watching.